And a prize will be awarded for the best question. And I now invite Stanislav Rakovsky, senior specialist at Positive Technologies, taking care of their snakes, the search for trojans in PyPI using machine learning. I'm happy to see both the known and new faces, familiar and new faces. Today, I'm going to tell you about things that is relevant always. Look for trojans on PyPI. And also, I have a few interesting things to say about machine learning. Okay. Some of you already know me. I work in Positive Technologies. I'm a senior virus analyst. Judging by a series of my presentation, you can see that I'm interested in things related with Python, and I'm bringing a little bit of good to this world, removing trojans. At the bottom of my slides, so there'll be a link to this presentation. You'll also be able to discuss this presentation, and even if we fail to meet face-to-face here, and even if you get a question after the Q&A session finishes, you'll be able to use it. So, security of open source projects. Because we are running an InfoSec and developer conference, I don't need to persuade you that the role of open source software is extremely high. You can see tools, and you're familiar with some of them, I'm sure, that cover different areas of activities, not only of IT, but people in general. We see tools to edit images, to make drawings, all sorts of ML-based things. And out of them, there are such things as TensorFlow, Ansible, Django, CV are written either completely or partly on Python as a language. Tyobi says on the current statistic that Python is a popular programming language, but Tyobi is a simplistic ranking. It's based on the number of requests, search requests in Wikipedia, Google, and other search engines. So it may not sound too convincing. But nevertheless, we see that Python is in the lead with quite a big gap. But I have a different ranking. PyPI also shows that Python is quite popular. This one is based on Google Trends, and again on search queries. But I mean, you may say that if the Python people want to boost them, they will. But we also have GitHub. It's a bit more advanced. It focuses on the statistic from GitHub, on pull requests, on stars, pushes, and issues. And here you can't get away. Python looks like a leader. And what we also see is that Python is indeed a popular development language. So the growth in Python popular is also highlighted by the growth of new releases in the main repository. If in the past, in 2022, I had to say that every time there are 5,000 new releases coming out, it's very difficult to analyze them. Now I have to say that every day 8,000 new releases come out, and this trend is growing, as we can see from here. So every Python person has encountered this in their experience. We have this library, we are trying to import it, but For some reason, it's not installed, and then the system complains. The next step, obviously, is to try and install this network as is. Actually, this is the wrong thing to do. There are several libraries where the names of the imported modules are different from the name of the library as such. So these are false friends of installers. And wrongdoers can abuse this, and they did that in the past. So instead of the original packet with such a name, they could apply the malware activity and to insert trojans in the work of programmers who are trying to install a packet with a different name head-on. Now there are plugins for most such packets, so that it shouldn't be allowed. So I have a question. How does pip work? I explained to you earlier. But look at these commands. And can anyone tell me or raise your hands who understands the difference of principle between these three commands? Cool. Actually, it looks like the first is just to pull the latest version of the request. Second is a specific version. And third option is about downloading a request, but using an alternative storage. And so pip is quite simple. It'll take your command, will pass the name of the packet. If there's a version name, it will also recognize the version and will go to a repository. If you haven't indicated, it will go to Python patch index. It will pass the HTML page, find the version that you want, and will download it. That gives rise to a lot of abuse because developers are people and then can make typos or they may download packets that are different in name. And so at different times, we could see people trying to download all these packages rather than requests. Luckily, they have already been deleted, but some of them existed for several days or even several months. Let's see what was behind them. For instance, there are 3 packets which contain such gibberish. There's gibberish that's even more sophisticated with hieroglyphics and with mathematics. There are versions that are simpler. For instance, trying to install a crypto miner into our system. So our computer, after that, or our servers, where we try to install this package, would try to generate money for somebody else. Or here, it's an example of a download Trojan. It will install a package. It will either be a Skiller or a Ratnik that will run its whole load. So it'll either steal something or will include your computer into the botnet. So one mistake and you've run into a problem. So, as I said, all these have been found out and deleted. So who does that? Quite a lot of InfoSec companies and researchers do that. In 2022, I analyzed the Python patch index, and at that time, it wasn't all that good. During 3 months, I found 148 malware packets, and in 2022, I saw that some of these packages dated back to 1218. That many problematic packages were there. With time, the situation improved. More companies started to contribute to this detection and analysis problem. And so almost every month, 1 or 2 papers are published either by vendors or other companies who mention different attacks. For instance, here, the request Darwin Light libraries mentioned, which contained an info stealer. Here again, we have an info stealer. So continuing on the tradition or the trend, here we have a grouping of North Korean Lazarus, and here an explosion. As part of these attacks, packages were identified existing from 1 day to several months, which is, impressive, because in the research of the 22nd of May, we found packages reported into the package index within 1 day, and they were deleted on the same day. On the 22nd of March, the researchers found that package index was closed for a quarantine, and then they identified that some wrongdoer added several hundred packages. At the same time, papers were published to offer very cool ways of looking for malware included into the package index, including information. But in 2024, I come back and scan on this package index using machine learning methods, and I find 28 malware packages in several dozen releases containing malware workload, collection of the information about the user system, installing a Trojan, installing a stealer, reverse shells. So the situation has not really improved. Malware packages still come up, and some of these have spent 18 months in the package index. So even though there are a lot of people analyzing the package index, these efforts don't seem to be enough. So malware packages, I listed all the stealers and trend unloaders. So what's that all about? Let's take a look at the purposes that a wrongdoer can pursue regarding ourselves. I am now showing you a typical chain followed by an info stealer. The first thing is to identify the goals, the targets, so what we're going to steal. This example shows paths to Discord and the browser where the Discord account can be contained. So the list is quite short, but it's not complete. This screenshot shows how to get data that could be of interest to the bad guy. In this case, they're just stealing session codes, Discord session codes. So they just download and pass, which is not too different. And the third, how to send this data, exfiltration, the sending of data from the victim to the wrongdoer. Here you see usual HTTP requests, so everything is that simple. There are more exciting examples. Info stealers, multifunctional info stealers steal information from several sources. For instance, the browsers. Here we see crypto wallets. We see accounts in gaming, services such as Steam, Nation's Glory, Riot Games, and we see Telegram. They said, apart from MBS browsers, MBS browsers have a little peculiarity regarding data. Under Windows, Microsoft crypto providers are used to encode your passwords. So you won't be able to just steal the folder. It has to be opened and decoded using the WinIP method, crypt and protect data. It's also quite interesting about Telegram. Telegram can also do some self-defense. It opens the folder with your profile in privilege mode that doesn't allow other people to interact with this folder even in the read mode. So the wrongdoers go, kill a Telegram, and get an opportunity to archive with your Telegram profile. So if you see that your Telegram blinks for a second while you're installing some package, this is the right time to get disconnected from the internet. And this stealing goes quite simply. The Telegram account can be sold for different mailing lists. A Discord card has a credit card linked, so these card details can be sold to boost different services. And or you can buy games or offer games to somebody else. So monetization is quite easy. And exfiltration there is done using a Discord cookie, Discord bot. So wrongdoers don't see a big problem sending the stolen data from the victims. So here we see the Trojan life cycle on PyPI. There are other chains, for instance, with the backdoor. In one of the examples where we had that gibberish in Chinese, in fact, the Python code was registering a JavaScript plugin in a Chromium-based browser. Here we see just a usual Clipper. It's a Trojan part that listens to the exchange, and if a crypto wallet is stored in the buffer, they are replacing it by some other. So if you're sending some money, the crypto wallet is replaced, and while you send the money to a wallet you think you're sending to, it is actually sent to the wrongdoer's wallet. So very simple stream. The third variant, it requires more actions, launching a reverse shell. These reverse shells are not new, but they still exist. They open before the connection to the wrongdoer server, and bash will start to redirect the IO stream to the socket. This is a standard approach of pen testers to get access to an interactive console of a Linux machine. There are several other scenarios. For instance, Trojan downloaders can start and run the next stage. There can be some more sophisticated malware hidden there. For instance, in a cat image, apart from the picture itself, there will be this code to run a file looking like a Windows update. So this file was an info stealer, actually. Another scenario, not really trivial. It's not so much about how the wrongdoer builds a chain, but how they're trying to avoid detection. It's a de-obfuscation. Here we see some frightening code, but those who've been dealing with Python malware can see some familiar parts. For instance, the first line, we see the encryption code, and in line 3 we have encryption key, and line 6 to 9 is the cycle code style. And in 12 we see that the decoded line will be evaled. So the obfuscated codes will be launched. Does it stand in the way for the audience? Yes, indeed, it does a bit, because we could put print instead of compile and get the workload. But if you need an automated solution, you should go to my earlier presentation at the Bison meetup. So basically, these are all the most popular scenarios that wrongdoers can use. This is not exhaustive. There can be wipers or meme libraries where you say, aha, I've broken your computer, be more careful next time. But they don't do anything. They just output this text. So we have a rough idea how Trojans look, what they do. And our question, how to identify them, how to detect them. So how will a person, a human, what will a human do? It's a question to the room. And I will be repeating your answer to the microphone to be recorded. So imagine you got some malevolent code, and what would you do if you were to scan? So you have source code arriving on input. How are you going to analyze it? By keywords. All right. A way was just presented in the room how we deal with usual vulnerabilities started us scanning in order to deal with Trojans just like with vulnerabilities. And just use the same principle and same set of rules or using dynamic launch. Okay, anymore. To take a Kaspersky engine and charge it on it. Indeed, Kaspersky works with quite a long lag, but some popular stealers, for instance, WASP, and it finds, looks for some stealers. I have Kaspersky for fun, and sometimes it complains about scripts, but it just ignores most of the scripts. So Kaspersky is not the best solution to look for malware code. Detect rules. For what? What for? Okay. We've already heard this version. Can you speak louder, please? Yes, not bad. You can use something like that to detect. Okay, as I understand, an option was proposed. So we've seen chains with stealers, how they describe what they're going to steal. Look at the mention of these paths to the browsers, to Telegram, to gaming services. Yeah, so we have this piece of code. And the first thing that a human will pay attention to when they see that will be the lines mentioning themselves. We see a path through local storage. We see extensions of interest to the stealer, login, LDB. And what's important, the regular expressions that allow the wrongdoer to get your session tokens for further stealing. There's another approach. We can focus on calls. It will be more unique. Here you will see schema or library calls. Let's go open Grafendo. Actually, this stream could be used to, or this string could be used to describe procedure to get any information using regular expressions. For instance, this one. with obfuscation. So little can be done, but again, you can focus on calls and requests. And we see eval compile. It's almost completely a detect of malware, because it's quite frequently used practice or to obfuscate malware code. But as I said, that just the fact of obfuscation doesn't mean that it's malware. There are such libraries as Cortico, Simple V. There are also email libraries that just want to protect the code, because it's basic intellectual property, and they don't want it to be disclosed. So, legit developers can also use obfuscation, and you can't say that if it's obfuscated, it's malicious. Of course, for people who do secure development and code analysis tools, they can say if it's obfuscated, it means that information, they're trying to conceal information, and it's bad. But in real life, the world is not so friendly as to be open. So, summing up, we can focus on lines, we can focus on the presence of calls, and also we can focus on strings of calls. So we got to the first part of the verdict creation process. So it looks like we can work with the project, extract features from it, and then we need to somehow process them and analyze them. A solution has already been mentioned here. People will most probably use the rule description just like as the one used to describe vulnerabilities. For instance, a simple rule for the describe engine might look like this. But I said that I'm going to talk about machine learning. So I'll be explaining machine learning at quite a basic level. So for the ML professionals here, please don't complain. Why didn't you mention technology X or method Y? So imagine we have a series of projects, and there's this factor of presence or absence of certain features there. So we have this matrix of projects, and well, whether these are malware or good. So first thing we see is that this spreadsheet looks like the one used in systems of algebraic equations. And indeed, we can try and enumerate a formula that will describe this law. It can be done, and it doesn't only give us a verdict, but also the certitude about this verdict, which allows us to not only look for matches such as eval compile, but for additional strings or for the partial presence of these strings. That will be expressed in the certitude of detect. So we see that switches A, 2 and 3 present, and it was decided that if features 2 and feature 3 are present, then it's a malware package. But again, this is based on very generalized data. When you have more features, you'll be able to play on that. But in this case, the formula is quite simple. Solution tree. This example is similar, but instead of using a formula, we use conditions. In this case, the presence or the absence of a feature. Here, our tree has decided to focus on feature 1, so if it's present, then the package is considered to be a malware. If it's not, then it's not. And basically, it copes with this data. So, it's also a good way to use the decision tree. The only problem with it is that one can set up such conditions that will synthetically match this verdict. So usually the trees are limited in the number of conditions, so they shouldn't adapt to your data and not work really well with data that you get elsewhere, but to find some common laws. Also, in the machine learning apparatus, there are a lot of different methods to aggregate, to classify, to segment, to regress. And here, for instance, we here a visualization on two parameters, max entropy and max number of code lines. Here, in red, malware packages are marked. We see that we can identify, apart from this rule, special zones where we can be quite certain that the package is malware. For instance, if the entropy is quite low, then perhaps obfuscation is used that uses intermittence of some symbols, for instance, 1 and L, and that will reduce the level of entropy. And such packages will get there. Or conversely, with entropy that is very high, more than a 5.5. But we see that clean packages can also have high entropy. And machine learning-based visualization of packages allows us to get a better familiarization with the information, with the data set, and find features that can be more informative when describing the data set. I couldn't help mentioning this hyped subject and ask LLM if it can find malware code or not. Actually, even open source Llama 3 with a size of 7 billion is quite successful in finding malware code. If you ignore the decoder layers and use Llama as a classifier, you can use it quite successfully in order to detect malware code. But the bad side of this method is that it needs several seconds for warming up if you use a CPU. And this makes the speed of LLM work slower. So we had the code base of several thousand, and so we had to cut it in different pieces to process separately. So BERTA could be used, and as part of analytics, BERTA was used. But it's too slow to respond. As to my research, where I mentioned 28 malware packages for the nerds here, I use such features as the distribution of top 10 symbols, distributions of entropy, maximum number of code lines, the length of code lines, and bigrams, Jasper code. I was just taking words, including them in bigrams, then selected the most frequent, less frequent, how frequently they're encountered in malware packages and in legit packages. And basically, I got quite good score numbers, which proves that machine learning can be successfully used to analyze open source packages to find malware. For instance, as a data sets, open source repository, OpenDog and registry, malware registry were used. They are available on GitHub. So you can start your journey from these packages if you're interested in this subject. So I've told you about how it all works, and now we have wrongdoers, everything's bad, we're doomed, packages have been in existence for several months, and then some developer of ours makes a typo and everything goes down the drain. How to protect ourselves? I have two approaches, but I'd like to ask. I still have some time. I'd like to ask you, do you have any ideas? So, just as lay people, not as an enterprise developer, I'm asking you, just normal people. You're welcome. Firewall?
Какой open source firewall есть?
What open source firewall do you know?
Установить самый первый firewall.
Install the very first firewall from GitHub. Okay.
Использовать Кондо. Я
To use Condo.
Уже на одном из
I mentioned this approach in one of the previous phases. I'm happy to see familiar faces.
Да.
Cool, yes, great. All the attacks that we've seen earlier, they're focused on finding our user accounts in browsers, in schema, and steal them. Docker doesn't have anything like that, because the environment comes from the image where no games or browsers are installed, so there's nothing to steal.
А какой прокси-репозиторий может использовать обычный человек?
Which proxy repository can a regular person, a regular file developer use? They're saying that Nexus Server has free versions. Okay, cool.
Виртуальное окружение не поможет нам.
The virtual environment will not help us, because we can use some WINV or PIC-X, but unfortunately, this package will be installed in our infrastructure, and they'll be able to go through our file system and find things that would be of interest to them, find the prey. So this solution doesn't isolate packages from our computer.
Но там все равно может быть
well,
разработчика протрояния,
it can be so that at a certain time a Trojan infested version will be launched. It's cool. I didn't expect anybody to mention Docker. So, for enterprise developers, indeed, ask yourselves why you don't have solutions of this type. So, if you're working in a company, if you heard my presentation, and you understood, if you've understood how we protect them, then go to your DevOps and ask why a mirror hasn't been deployed. If you have a mirror deployed, good job. But in addition to the mirror, you should also use quarantine policies. Because in the situation where malware packages arrive once in several weeks, a quarantine for 1 to 4 weeks is a good idea. Also, many people have corporate enterprises, mirrors, I'm sorry, but no developers I've seen have these repositories released or rolled out on developer machines. Developers go to original resources rather to the mirrors. And this looks quite strange to me. So if you're of interest, please try and set up PyPI or NPM so that you should only work through your internal repository. And the main advice is to use Docker for the same reason. There's very little information that can be abused in Docker. Of course, there's a way to get a problem with the Docker if you haven't updated it for a long time. Luckily, the package index over the entire history of my observations, I've only seen that I haven't seen Docker-based exploit, for instance. Identify Docker environment, get into Docker, and then try and prey on what the developer has on the computer. JetFrain, as part of Charm, allow setting up Docker as a developer environment. And yes, come to presentations like mine more often. Keep an eye on all the news about what wrongdoers can do, because awareness is the best strategy. It's better to know what the thieves can use to get something from you than to close your eyes on that. So I would like to thank everyone for your attention. Thank you. So, friends, again, next time, but we're getting new people, and therefore I will remind you once again, we are asking questions via the chat bot. Please scan the QR codes, and the best question will get a prize. Yes, Alexander. Alexander, who's here? He loves asking questions at Moscow Python meetups, a lot of questions. I'll be very happy to take them. And by the way, that link is there. So you'll be able to get in touch with me using this list if you don't find me on the sidelines here. Yeah, actually, there are quite a lot of questions. We'll try to take them all. The names of remote repositories, don't they reserve services providing them so as not to be reused? How can the repository respond? Regarding the package index, regarding the Python package index, its administrators have already banned several popular names, such as, for instance, request without S, request without S at the end. But this list is quite short. And after a package is reported, it is usually deleted, and this name remains available for repeated registration. Maxim Malchuk, how to get protected from a Trojan, even if Nick and SYK doesn't find it. Write your own libraries. Well, if you're a data scientist, you can fully migrate to Condo. Condo is a moderated repository. People who are hosting it are looking through these packages, making sure that they are not evil. And as a result, but as a general recommendation, use Docker. It's an ultimate option presently, allowing you to get rid of this problem. Tiana is asking, does it make sense to use an antivirus like MAV in the connection with the proxy storage? Does Python use any mechanism to verify packages? I think I know who asked this question. Yes. PyPI has a quite long history fighting with packages. At a point in time, they even use the Yarrow rule in order to identify malware inserts. It's just the code rules, the mention of evals and others. But these rules were only sent as alerts to administrators of the Python package index. And some packages were published. So the administrator had to look at the package, understand that it's malevolent, malicious, and delete it. In 2022, we started reporting packages. We reported about 15,000 of them. And at some time, perhaps they got sick and tired of that, and they create an API for that. So now there's a closed beta. You can join it. It's is described in the package index blog, and it can be used to identify malicious packages. Also in the PyPI interface, if you're a registered PyPI user, you can report a malware package to us. Now, Python package index actively interacts with InfoSec vendors and enthusiasts to look for malicious packages. So themselves, they are only an infrastructure operator, and they also validate our verdicts. Thank you. Daniel, 159X. Thank you for your presentation. How these malicious packages are found by classic tools such as sandboxes and AVs? Look, for the AV, it's mostly based on detection rules. So there are people just like myself. They write rules manually, and then these manual rules work. Of course, there's a machine learning mechanism, but I don't have any details about this, how Kaspersky uses that. Can you repeat the question? I just forget what was following. How are these packages found by classic tools such as sandboxes and AVs? Oh, yeah, okay. So the AVs don't do a good job finding them because to do it, they need to have like a section with rules on open source, whereas the users here are just developers, so it's not considered to be high priority for the broad audience. As to the sandboxes, as I understand, for sandboxes, it can be a bit of a problem because in order to load such a package into a sandbox, you need to have npm ruby pip installed, so that the commands to install this package in the sandbox could be launched. Also, internet should be available in the sandbox for the package to be downloaded. But even this way, in some malware packages, there are methods to handle popular sandboxes. I won't say that all of them. I won't say that enterprise ones are more prone, but I think it might well okay for a normal development, whereas for scanning packages from such platforms, it's very resource intensive. Okay, thank you. Aristark is asking, in your opinion, how critical can be attacked using Python compared to other languages, both low level and high level? I think they're extremely dangerous. The problem is that wrongdoers are invading in the development chain of the company. And by infecting a developer, what you get is that it's not just an info stealer gets in your system as a private individuals, your gaming accounts, Discord accounts, but if as we have a remote admin tool as payload, then the wrongdoer will have full access to the developer environment, and the options of what they can do are only limited by their imagination. They can add a utility that will do something in the company's infrastructure. They can encrypt the environment and demand ransom. Yes, so they're limited only by their imagination. In case of traditional Trojans, there are quite a lot of solutions, ADRs, antivirus. So with classic Trojans, they handle very well because that's what they have been designed for. But in case of packages that developers are using, this is an area that hasn't been researched too well. Okay, we're running out of time for questions. Dear friends, well, unfortunately, we won't be able to take all of your questions. There's been a lot of questions coming. But, I mean, you can get in touch with Stas on the sidelines. Stas, again, how the life cycle of a Python Trojans is different from a Trojan life cycle in C++. Well, unfortunately, I am not competent enough to answer this question, simply for the fact that I don't know what open repositories are there apart from GitLab, GitHub, and Git. I just don't have the knowledge. Okay. Two facts. Your opinion. What's the least evil? I think total manual control It's better. Quarantines,
пакетов, ответственность того, кто
passing the
добавляет определенную
packages,
версию пакета в локальный
accountability of those who are adding packages to the local internal repository. Developers who want to add a new package, they have an interest in this package
так повесить на
to
них
be present in the remote in the internal repository. So make it a duty for them to go through it. Of course, it's difficult to go through Ansible; it's huge, but I mean, you can put responsibility on them. You can
сервиса ПТ
make them analyze packages like service and app analysis.
и
You
другие
can use application inspectors or other utilities in order to find such backdoors. Why not? Total control is better
одна ошибка
because, as somebody said, one mistake and you're in error.
переносный пакет достаточно
So downloading such malicious packages is quite a simple thing to do. Quite often, developers are just swarmed with trojans, and they install malware-infested releases with the same version of the package.
все-таки контролировать.
So it is better to keep this thing under control. Okay, let me ask
от двух человек вопросы, к сожалению, еще раз, друзья.
two more questions. Unfortunately, friends, most questions I won't be able to ask them. Let's do it in blitz mode because time is really running up. That's actually run up. So, Sergey, the approach that you're using, does your company use the proposed approach to verify imported projects? Since 2022, since May 2022, we included the package moderation process in our internal repositories. Is this approach applicable for repositories of packages for other languages such as Rust-Race.io? Are you aware of such work or research?
Помимо Python Package
Apart from Python Package Index, there are a lot of malware packages in NPM, and there are also researchers who are looking at the packages, report them, but that's a different story. It's a different language that, unfortunately, I don't know well enough. And the last question from Albert.
Поскольку Python, к сожалению,
Because Python
временно заканчивается. Поскольку Python достаточно язык, что если
is quite a flexible language, what if the code would contain a new obfuscation method that hasn't yet been treated as a sign? Well, there are several solutions to that. If this is about obfuscation, then perhaps this package could fail the entropy test. Machine learning has a special section on outlier analysis. Such obfuscated codes will contain different numbers of instructions. So if it's obfuscated with 128 for cycles, it's also an outlier. Even if it doesn't have any malware code, it can still show. And basically, any event of obfuscation will affect some metrics of this code. And this can be used as a foundation to detect such packages. And at the very extreme, you can use a de-obfuscator. I don't know any standard ones for Python. We have our own that we can use. There will be a link in the blog. And basically, sandbox, just like at the ultimate solutions that can potentially fix your problem. So thank you, Stas. You now have to choose the best question. Friends, we've only run through about 1 page and a half, whereas we have 5 pages of questions here. So I'm really sorry that we haven't been able to get all of them answered. But you'll be able to get in touch with Stas on the sidelines and talk to him directly. I liked the question about enterprise search, how companies get protected, how the company get protected. Just wait a minute. No, it's surely somewhere there. Manual control? Oh, yes. It's about total manual control. Two-fed. Who is this person who is two-fed? Yes, here we have the man. Good, he's present in the room. Congratulations. Give him a hand. Give your applause to Stas.